Welcome to Brain Vision.
So for part A, they're asking us to find the moment of inertia about an axis that is perpendicular to the plane, passing through the point where two segments meet. So we have this little diagram here. We're going to say that this is A, this is B, and this is C. And we know that this is L over 2, and that this is also L over 2. And at this point, we can say that this mass is going to be m over 2, and then this mass is also m over 2. So a moment of inertia about AB. So the moment of inertia about these two, about this segment here would be simply ml squared over 3, where L equals, where m equals capital M over 2. L is going to be L over 2 squared. And this is all divided by 3. ml squared over 24. We do the same thing for this segment here, BC. And this is going to be, again, ml squared over 3. And this is going to be m over 2, L over 2 squared over 3, ml squared over 24. And then according to the parallel axis theorem, the moment of inertia about an axis perpendicular to its plane, passing through the point where two segments meet. So right here, perpendicular to this point, passing through this point, however, perpendicular to the plane. And then, but here is where two segments meet. This will be AB plus moment of inertia BC. And this will be ml squared over 12. So this will be your answer for part A. And then part B. So part B is asking us to find the moment of inertia about an axis perpendicular to its plane and passing through the endpoint, passing through the midpoint of a line connecting its two ends. So here it's a bit more complicated in the sense that we need to draw a little bit of a bigger triangle. We are going to label this here, here, here. So this would be A, this would be our A prime, this will be our B, this will be our B, rather, this will be our B prime, this will be our C prime, this will be our C prime, and this will be our C. We're going to have to, we'll just draw a dotted line in order to show how we got that. So this B prime is considered the midpoint of AC. So we can say that the center of mass of AB would be considered A prime, and then the center of mass of BC would be considered C prime. And we can say that A could be denoted as 0, comma L over 2. This would be considered 0, comma L over 4. This would be considered 0, comma 0. This is simply coordinates if this was laid onto an XY, like classic Cartesian axis. This would be L over 4, comma L over 4. This is L over 4, comma 0. And this would be L over 2, comma 0. So at this point, we have to find the center of mass. So the center of mass for our x coordinate would simply be m1 x1 plus m2 x2 all over m1 plus m2. And we can substitute and say that x sub m, x, the x coordinate of the center of mass, rather, will be m over 2 times 0 plus m over 2 times L over 4, all over m over 2 plus m over 2. And this is going to be equal to L over 8. Similarly, for the y, we have the y center of mass. It's going to be y1, x1 plus y2. Rather, my apologies, m1 plus y2, m2 will equal, rather, divided by m1 plus m2. And again, we're going to have to substitute. So the y coordinate of the center of mass is going to be L over 4 m over 2 plus 0 m over 2, all divided by m over 2 plus m over 2. And again, this is going to be L over 8. So at this point, we can say that, let's get a new workbook. We can say that the center of mass is going to be D, and this is going to be L over 8, comma, L over 8. And if we were to draw this, it would be somewhere here. So this would be our D. And essentially, we're trying to find, again, we're trying to find the moment of inertia about an axis perpendicular to this plane, however, passing through the midpoint, so passing through here, passing through a midpoint of a line connecting its two ends. So yeah, so we're going to try to find the moment of inertia of IB prime. So the moment of inertia of B, however, can be considered ml squared over 24, and we found this in the over 12, and we found this in the first slide. We found this in the first part of the question. And we know that IB can equal I center of mass minus mx squared. This is the parallel axis theorem. Where x would be the distance between the axis passing through the center of mass and the axis passing through B, so point B. And if you were to find x, x is going to be equal to L over 8 squared plus L over 8 squared, quantity to the 1/2 power. So this is essentially due to Pythagorean theorem. And this is going to be equal, rather, we can say that conveniently, we can say that x squared is going to be equal to L squared over 32. And at this point, we say that the center of mass is going to be equal to I sub B minus mx squared. And this is going to be ml squared over 12 minus ml squared over 32, 5 ml squared over 96. And once we find this, we can then say, okay, IB prime is going to be equal to ICM plus mx squared. And we can use this to essentially, this would be plus rather, and this would be minus. We can use this, the moment of inertia of the center of mass, in order to figure out the IB prime. So IB prime plus mx squared. Again, x is that distance between this axis and this axis. And we're trying to find IB prime, which is the moment of inertia perpendicular to the plane, passing through the midpoint of a line connecting its two ends. So we have IB prime equals ICM, which we know is 5ml squared over 96, plus, again, ml squared over 32. And this is going to be ml squared over 12. This will be our answer for part B. And that's the end of the solution. Thank you for watching.